Mars, our planetary neighbor. It's very cold and dry, and its weak gravity only holds a thin atmosphere. As probes started to visit the red planet, we gained a more accurate view of the surface, and scientists began to wonder. Mars had once been much warmer. It had rivers, and in its early years might have sustained life. A succession of new techniques have been deployed trying to unlock the secrets of the red planet. And while our knowledge of the Martian geology, its atmosphere, and its weather has grown immensely, each new mission to Mars raises more questions than it answers. We still don't know if Mars has, at some time, been a home to life. In 1877, astronomer Giovanni Schiaparelli made what he thought was the most accurate map of Mars yet drawn. On it, he showed canals. In the early 20th century, American astronomer Percival Lowell was convinced the canals were signs of a civilization existing on the red planet. So began the search for life on Mars. In 1962, the Soviet Union sent the first probe, the Mars M1, on a flyby mission. It was an audacious project, and it failed. The first of many failures by both the Soviet Union and the United States. Cold War rivalry provided the motivation for these early missions. In 1971, NASA sent Mariner 9 to Mars. It was the first probe to orbit another planet, but scientists discovered that Mars was enveloped in a planetary dust storm. On-orbit photography revealed little more than a red cloud. Soon, Mariner 9 was joined by two Soviet orbiters, both equipped with landers. The Mars 2 lander crashed, but the Mars 3 lander made it to the surface intact. It returned one garbled image and then stopped functioning. Mars now had 3 orbiting spacecraft, all looking at a dusty, featureless planet. The two Soviet probes were identical, but the American probe had one key design difference. While the Soviet orbiters began photographing the planet following predetermined schedules, NASA were able to command Mariner 9 to wait, in hope that the dust would eventually settle. It took months for the atmosphere to clear, but when it did, Mariner 9 saw 3 craters protruding above the dust. They were the tops of giant volcanoes on what was called the Tharsis Plateau. Soon more complex geological features began to emerge. In places, the surface was cratered, suggesting the tectonic forces that constantly renew the Earth's surface were absent on Mars. Volcanic activity that built the solar system's largest volcanoes had stopped billions of years ago. This enabled NASA scientists to compile an accurate global map of Mars and to decide upon landing sites for the Viking probes that followed in 1976. Viking 1 and 2 were identical orbiters, with landers that both made successful landings on the surface. Both returned pictures of the Martian landscape. The primary objective of the Viking program was to find signatures of life. But researchers now feel the 3 experiments tasked with carrying out the analysis had limitations. As researchers on Earth began looking for traces of life in extreme environments, they began to rethink where life on Mars might survive. Yet the consensus at the time was that Mars was sterile, and the idea of life on Mars died. After a 20-year hiatus in Mars research, Mars Global Surveyor went into orbit in 1996. The pictures it relayed back were clearer than anything yet seen from the Red Planet. Although most Mars orbiters had been tasked with mapping the planet's surface, this was different. The high-resolution images that the Mars Global Surveyor sent back revealed rivers and even river deltas, but the occasional impact crater suggested that nothing has flowed in these systems for billions of years. In July 1997, another probe arrived. The Mars Pathfinder was one of a new breed of missions being pushed by NASA's new administrator under the guiding philosophy of faster, better, cheaper. The idea was to cut development times, cut budgets, and although the risk of failure would rise, the reduced price tag could mean more missions. Pathfinder would land a small rover on the surface. To do this, it used radically new airbag technology. The technique drew more from automotive safety systems than from previous space missions. The landing site, in Mars' northern hemisphere known as Ares Vallis, is one of the planet's rockiest areas, yet it was thought to be a safe area to land. The broad array of different rock types are believed to have been deposited during an ancient flood. The new landing technique worked perfectly and served as a proof of concept that would be used on future missions. Pathfinder consisted of a base station equipped with 3 solar panels that unfolded like petals. There were sensors to measure atmospheric pressure, air temperature, and wind speed, as well as a transmitter to communicate with Earth. In addition, Pathfinder acted as a base station for the Sojourner rover that explored the surrounding area. Sojourner was fitted with cameras and an alpha particle X-ray spectrometer. It was the first mission to have its own website. The rover returned thousands of images and important detail about the atmosphere and geology, and its popularity guaranteed more Mars missions. On the morning of April 7, 2001, another Mars orbiter was launched. Mars Odyssey was equipped with 3 primary instruments, and it had the ability to act as a relay satellite between future surface missions to the Red Planet and Earth. On its arrival at Mars, it used a new technique to go into orbit. After firing a relatively brief pulse of its engine, Mars Odyssey went into a highly elliptical orbit that, at its closest approach, had it skimming the planet's thin upper atmosphere. Called aerobraking, this technique allowed the craft to circularize its orbit over a period of 3 months, and it saved around 200 kilograms of fuel. The probe is still in operation today, breaking all records as the longest-serving Mars mission. In December 2003, a new player arrived at Mars. The European Space Agency, using a Russian launcher, had sent Mars Express, its first planetary explorer. It was equipped with a lander known as Beagle. Though all contact was lost with the lander, Mars Express continues to return valuable data. The mission has been granted several extensions, the latest till 2020. Equipped with a high-resolution stereo camera, the probe returned unique 3D views of the planet's surface. The orbiter determined that the polar ice caps contain a blend of frozen CO2 and water ice. In the atmosphere, Mars Express detected first methane and then ammonia. Both gases deteriorate rapidly in sunlight, so there must be sources on Mars continually producing them. Methane and ammonia can rarely be made inorganically, but they're generally associated with life. 1 month after Mars Express went into orbit, a NASA lander arrived at Mars, followed 3 weeks later by a second identical craft. They were the Mars exploration rovers called Spirit and Opportunity. Spirit, the first to land, was targeted at the Gusev crater. Opportunity would land at the Meridiani Planum on the opposite side of Mars. Though they were much heavier than their Pathfinder predecessor, they used the same bounce landing technique. Both landings were successful and on target. After the craft had righted itself, it detached from the lander and began autonomously unfolding its solar panels and camera mast. While this was happening, the team back at the Jet Propulsion Laboratory waited. Signals confirming the craft's safe arrival took 15 minutes to travel back to Earth. Many of these people had invested years of their lives in this project, and the real mission had only just commenced. Both rovers were designed to operate for 90 Mars days. A solar day on Mars is about 40 minutes longer than an Earth day. And to avoid confusion, the science team operating the rovers refer to a Martian day as a sol. Mission designers, knowing about the dust storms on Mars, felt that the solar panels on the two rovers would eventually be blocked with dirt and stop functioning. But it became clear that the winds on Mars were clearing the panels. Soon, NASA announced that Opportunity had found evidence confirming liquid water had once flowed on Mars. There were pictures from the Meridiani Planum of stratified patterns in the rock suggesting sedimentation. The distribution of chlorine and bromine at the site were clues to the areas past as the shore of a salty sea. In April 2004, NASA announced it would extend the rover's missions from 3 to 8 months. It would be the first of many such mission extensions. The rovers were equipped with an abrasion tool to grind away a portion of a rock's surface for a more detailed, uncontaminated analysis of geological samples. This was first done by Spirit at a rock named Adirondack at Gusev crater. It was a first in planetary geology. Researchers agonized before using the tool because of the drain it makes on the rover's energy budget. The rock was made of olivine, pyroxene, and magnetite, making it very similar to volcanic basalt on Earth. When Spirit's right front wheel stopped working, engineers used a duplicate rover to devise a reversing technique that enabled the rover to drag its frozen wheel. This left a furrow behind in the soil, which presented a new area of research for the science team. White or yellow deposits seen within the furrow were various types of salts that only form in the presence of hot water. On Earth, hot water provides an environment in which microbes can thrive. Spirit limped on for another 3 years before it became stuck in loose sand. Again, the engineers began working with a replica which they placed in an identical situation. When nothing was able to free the rover, it was declared a stationary research platform. Further attempts were made to position the rover so its solar panels could operate more effectively, but even this was not possible. The last communication from Spirit was in March 2010. Opportunity lasted until June 2018, when dust clogged its solar panels. In March 2006, NASA's Mars Reconnaissance Orbiter arrived at Mars and began the now routine business of aerobraking. Though this procedure took roughly 6 months, the saving in fuel will see the craft functioning at Mars into the 2030s. One of the primary functions of the new orbiter is as a communications relay station. Its 3-meter antenna transmitting in the ultra-high frequency band enables very high data rates. By November 2013, it had tripled the amount of data sent to Earth by all the other NASA missions combined. Its high-resolution camera began revealing the surface of Mars in the finest detail. These are active falling dunes in East Copretes Chasma. The polar region, free of the seasonal dry ice, again surrounded by dunes. In the southern hemisphere, pits in the residual cap of carbon dioxide. The poles of Mars were now attracting keen interest. Follow the water had become NASA's catch cry. The Phoenix lander was targeted at the northern polar region to follow up on information from Mars Odyssey suggesting frozen water lay beneath the surface near the poles. Because imaging had revealed the region to be unvarying, a rover was deemed unnecessary. The lander had been designed to use a parachute to decelerate, with rocket thrusters to deliver the craft to the surface, unlike NASA's previous 3 rovers, which had bounced. This decision proved controversial, as one strand of research suggested the rocket fuel would contaminate the very area that the lander was tasked with analyzing. The craft waited 15 minutes to allow any dust to settle before it deployed its solar panels. Phoenix had landed during the early spring in Mars's northern hemisphere, so the solar panels would receive plenty of light for the planned 90-day mission. As well as its camera mast, Phoenix was equipped with a meteorological station that recorded the daily weather. It featured a wind indicator and pressure and temperature sensors. In addition, a vertically pointed LiDAR was able to observe cirrus clouds forming in the region and snow falling in the polar atmosphere. These phenomena had not been observed before. The lander also had a robotic arm that could dig half a meter into the soil and deliver samples to the analyzer, a combination of 8 high-temperature ovens and a mass spectrometer. In one excavation, the cameras recorded a white substance which gradually disappeared. Given the temperatures and the time it lasted, it could only have been water ice that sublimated after it was exposed. The soil was slightly alkaline, and the presence of perchlorate, which kills bacteria, was not good news for those hoping for Martian life. Phoenix operated for 2 months longer than planned before the gathering winter completely shaded its solar panels. While the planet still had subterranean deposits of ice, there was precious little left at the surface, yet it was now understood that many of the red planet's features had been carved by running water. Samples analyzed from across the planet affirmed that water and nothing else had made these changes to the Martian landscape. Mars had once been more like Earth, yet it had lost its surface water and most of its atmosphere. And the question of life persisted. Could it have emerged in a warmer, wetter past? And could it still be present below the surface? The next Mars mission would be NASA's most ambitious yet. Known as Curiosity, the car-sized rover would be powered by a nuclear battery, making it immune to the dust problems experienced by Spirit and Opportunity.
7, 6.
Curiosity was launched on an Atlas V from Cape Canaveral in November 2011.
1. Main engine start. 0. And liftoff.
In mid-2012, it entered the Martian atmosphere heading for Gale Crater. The Jet Propulsion Laboratory monitored the entry closely, but had no control over events. In Mars's thin atmosphere, the parachute could only slow the heavy craft to around 320 kilometers per hour. Nearing the surface, the rover descent stage dropped out of the aeroshell and rockets kicked in. At this stage, radar was guiding the lander to the surface, and a small camera was recording images of the terrain below the rover. Next, Curiosity was lowered on a tether beneath the descent stage. This sky crane technique was used to avoid too much swirling dust exposing the rover to unnecessary danger. Everything had worked exactly as it was supposed to, and the American engineers were relieved. The landing had been the most precise ever. Before Curiosity could start work, its computer went through a checklist to make certain that all systems were operating correctly. It was a day before the rover deployed its camera mast and communications antennas. It's thought that Gale Crater is 3.5 billion years old, and that its sediments have been laid down first by water and then by wind. NASA now has a sophisticated mobile science laboratory on Mars, connected to Earth by the most advanced communications link, courtesy of the Mars Reconnaissance Orbiter. The rover's primary objective is to discover if conditions suitable for life ever existed or still exist on Mars. It's also gathering detailed information about the current conditions on the red planet, particularly the radiation levels that will have an impact on proposed manned missions. Curiosity has analyzed the dust from a number of holes it drilled, revealing sulfur, nitrogen, hydrogen, oxygen, phosphorus, and carbon, all elements essential to life. In its 6 years on the surface of Mars, Curiosity has traveled around 20 kilometers, but the driving is taking its toll. It routinely sends back a series of self-portraits, mainly for diagnostic reasons. Its wheels have taken severe damage, which will undoubtedly lead to design changes for future rovers. Its computers are also giving problems, but a new suite of missions is slated to arrive at Mars in 2020 that will continue profiling the planet. There is one aspect of the Martian environment that has never been investigated, but that's about to be addressed. The Mars InSight probe has been targeted at the flat Elysium Planitia, close to the equator, to spend 2 years investigating the planet's interior. It made a flawless landing in November 2018. After unfurling its solar array, it spent weeks selecting a suitable spot to deploy a seismometer onto the surface to monitor Marsquakes. It's clear that Mars had a warm, wet past, but it's cold and very dry now. Learning about the planet's geological activity will help us know why Mars has changed. The InSight probe also hammered a thermal sensor into the surface to gather data on heat flow from the planet's core. By understanding processes within Mars, we can learn how the geological histories of Mars and Earth began to diverge.